This is Chapter 5 pre-class lecture, Part 4B. So in this part, we're going to talk briefly about how water is treated in a municipal water treatment plant. And so the picture below shows the typical components of a water treatment plant. There are various components that have various purposes. And so when water is taken out of a surface water area, such as a lake, water is pumped into the water treatment plant. And first, the water will go through screens. And the purpose of the screens is to remove large suspended solids from the water. And then, after the water passes through the screens, the large particles get trapped in the screens. And then the remaining water passes through, and flocculating agents are added to the water. Now, these flocculating agents are chemicals that are added that will cause smaller particles that didn't get trapped in the screens that are still in the water. It'll cause those small particles to clump together and form what's called a flock, which is a big, heavy, gelatinous type of particle due to those small particles that didn't get trapped in the screens clumping together. And that's what the flocculating agents do, cause these small particles to clump together and form what's called a flock when it goes through this component called the flocculator. And that flocculator has blades that spins the water at very, very high speeds. And that causes these small particles to clump together and form what's called flocks. And then those flocks then are so big and heavy that due to gravity, of course, and the laws of buoyancy, those big heavy flocks will sink to the bottom of the settling tank, and the pure water will pass right on through and not settle. And then the water with all the solid particles now should be removed totally now, once that water passes through the settling tank and those big large flocks fall to the bottom of the tank. Then the water is sent to a container that contains things like charcoal and sand to do filtration. And the flocculating agents are a combination of various chemicals, mostly organic in nature. And so the charcoal and sand filter will remove these organic compounds from the water. Because if these compounds aren't removed from the water, it could affect how the water tastes and how the water smells. Next, the water then is moved up to a chlorination phase. And the chlorination removes bacteria and other microbes. And then next is fluoridation, which is just an added measure to prevent tooth decay. Our water has fluoride in it. And then the water is placed in a storage tank. Now, chlorination is very controversial because of the chlorine chemicals. Some other alternatives that have been used instead of chlorine-based compounds are things like adding ozone or using UV light to kill the microbes instead of chlorine. Now, purifying water, like you saw in the water treatment plant, is very important, but also places on the planet that have water shortage issues. One thing that has been proposed is to use ocean water or seawater that is salt water and have that be an alternative to solve the water crisis issues. But seawater has salt in it. So you need to desalinate the water, and you use the process of distillation to do that, which is basically boiling the water and letting the salt settle, boil away the pure water, and then you condense the water and turn the water vapor back into a liquid, and you've got pure distilled water with no salt. Another possibility for purifying water, especially water that's been contaminated with bacteria and other microbes, is the process of reverse osmosis. Osmosis is passage of water through a semi-permeable membrane from a solution that is less concentrated to a solution that's more concentrated. Reverse osmosis, of course, is the reverse of this, in which you're moving water from an area that is more concentrated with other stuff in it, impurities, and then changing it from being more concentrated with impurities to being less concentrated, and therefore having no impurities. And this is a picture of the reverse osmosis process. And that brings us to the end of part 4B.